the first subject we're going to talk about is something called modular arithmetic. And modular arithmetic is it's to do with remainders, okay? And remainders are something you have not seen in a very long time, probably. You might remember when you were in primary school or when you were very young and you learned division. Say, for example, you were asked to divide 13 by 5, okay? Well, 13 doesn't go evenly into 5, so you would be told that there was, it goes in 2 times with a remainder of 3. And then later you do fractions and you're told, well, now we forget the remainder and we carry on the, you won't need a calculator today, okay? I will do everything explicitly as we go along. The remainder is actually something very important, and a lot of properties of numbers are specifically tied to their remainders upon division. And I want to talk a little bit about this arithmetic of remainders, which is called modular arithmetic. And modular arithmetic is massively important. It is not something I am showing you just because it's interesting and because I like it, even though I do think it's interesting and I do like it. Modular arithmetic is the foundation of encryption. It is the foundation of encoding of almost any kind. It's the foundation of random number generation. It is an immensely applicable topic, okay, particularly for people who are interested in computing on any kind of scale where you require secrecy or security or safety. So security is where you can send a message and only the person who you send it to can read it. And safety is that the message is received at the other end intact, which is not an easy thing. So there's safety and there's security, and you want to ensure both. And modular arithmetic is important in ensuring both of those properties. Okay, so what if you did foundation maths? This is not at all dependent on what you did for your leaving cert. Okay, what I'm going to talk about here is dependent on what you did in primary school. Okay, so basically for the first, I don't know, month and a half, if you can add, subtract, and divide, multiply and divide numbers, I can teach you how to do this. Okay, you don't need to know what a quadratic equation is. You don't need to know what a derivative is yet or anything like that. And when I do need maths from secondary school or something like that, I'm happy to review it. I'm happy to explain it. Okay, so please don't have this panic going in that somehow this is going to be difficult. Actually, typically the results are quite good. Okay, so I hope everyone will be very comfortable with it. So I'm going to start on modular arithmetic, and I'm going to switch the camera over to the camera that's over my shoulder, and I'll work on the pad. Okay, so can everyone see the pad? Responses, please. Is everything okay? Great, thank you very much. I just need one or two to let everyone to be told that it's working. Okay, so I'm going to write with a marker here. Okay, and hopefully that will come up clearly. And then what I'll do is I'll remove this page, move it to the right, take it out, and continue with the next one. So you'll always be able to see the preceding page. Okay. And for anyone who wishes to follow along, you can look at the notes in modular arithmetic, although honestly, that's not massively important. If you want to just pay attention to what I'm saying and look at what I'm writing down, everything is going to be here. So the first thing I'm going to talk about is called modular arithmetic. Let me know if this is large enough that you can all see it. Is that clear? Great. Okay. Let me know if I start writing too small or anything like that. I'll try to make it as good as I can. This is a tremendous waste of paper, but it's the best I can do given the circumstances. So what is modular arithmetic? It's an arithmetic of remainders. Now, a remainder is something that you were probably taught about when you were very young, but you probably have not seen in a long time. Okay, so let's do an example of a remainder. Just so everybody's clear what we did it in Python. Okay, great. Just so I can say something as a simple example, just to get back to an example of a remainder. If I take for example, 12, and I was to divide that by, we'll say 5, that would be 2 with a remainder of 2. Okay. Now it turns out that for a lot of applications, I don't actually care about this number here at all, which is the amount of times that I go in. In fact, let me give another example just because it's 2 and 2, and that's maybe not super clear. Let me do 13 with 5, which would be 2, and a remainder of 3.
Is he saying anything?
Can people not hear me?
Is he speaking right now?
I'm speaking right now. People are saying they can hear me. Some people are saying they can't. Have you muted my feed? Okay, great. Thank you. Can we get back on track? Can only the person who was asking that question, can you hear me now? Okay, no response there. We'll do my mid-90s Nokia test, which is, can you hear me now? Question mark. Can you hear me now? Okay. Well, I'm going to have to continue anyway. Please just make sure that if you're watching me that you've unmuted my microphone. He left and is rejoining. Okay, great. Again, remember, if you have technical issues, the video should be here for you to refer back to later. Okay, so it turns out that in a lot of instances, the actual number, the divisor, isn't super important. What's important is the remainder. Okay, so let me talk a little bit about how this works. Okay, I would like you to imagine the remainders for division on 5 arranged in a clock. Okay, so this is not a clock of 12, this is a clock of 5. So we're going to go 0, 1, 2, 3, and 4. And these are the 5 possible remainders that I can get on division by 5. Okay, and we're going to talk a little bit about how this works. Okay, so say I want to find out what any number would be on division by 5. Let's say here, I'll start with 13. Okay, the number I worked with before. I start at 0, and now what I'm going to do is I'm going to take 13 steps around the clock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 13 would bring me to the remainder of 3. It doesn't matter how many times I've gone around the clock, and it does not matter which direction I've gone around the clock. We'll see that with negative numbers in a moment. What matters is where I end up. Okay, so let's pick another number. Let's pick the number -9. Okay, so what would I do with -9? Well, now I have to take 9 steps, but instead of going in the clockwise direction, I have to go in the anti-clockwise direction. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would mean that -9 would give me a remainder of 1 in this system. And that's not something people are very comfortable with initially, is finding remainders for negative numbers. And we'll talk a little bit about how you can see that a bit more obviously. But for the moment, just think about the numbers arranged around a clock. Okay. Now, I can also talk about the addition of remainders. So for example, if I have a remainder of 1, and I want to add on a remainder of 3, what do? Well, then I just start at 1, and I take 1, 2, 3 steps, and that would be the remainder 4. Okay, so the arithmetic is very simple. Okay, if I started with 2 and I wanted to add 2 to it, I would start at 2 and I would go 1, 2. Okay, here's the important thing. What if I started with 3 and I wanted to add on 4? Well, then I would start at 3 and I would go 1, 2, 3, 4. I move through 0 and come out the other side. Okay, so in my system of remainders, 3 plus 4 is actually going to give me a 2. Okay, we'll talk about why that is arithmetically in a second, but I just want you to see the clock for a moment. What do I do with multiplications? Okay, how would I handle a multiplication? Well, let's say I had 2 and I wanted to do that 3 times. Well, then I would go 1, 2, 1, 2, 1, 2. So in this system, 3 times 2 is not 6 because there is no 6. As I move around the clock, I would see that 3 times 2, if I multiply them in this system, I would have to get a 1. Okay, and of course I can do subtractions by doing additions the opposite direction, and divisions are hard, and we're going to have to talk about them later. Okay, so this is the basic idea of a clock. Okay, now the term I want to introduce here is kind of a fancy word, but it doesn't really mean anything. It doesn't really mean anything too significant. It's called equivalence. And I always spell equivalence wrong. By the way, I have a doctorate in mathematics. I do not have a doctorate in English. I believe it's ANCE in modular arithmetic. Okay, so now the numbers in this system of mod 5, okay, I only have the numbers 0, 1, 2, 3, and 4. However, there are, of course, other numbers that exist in the integers or in the natural numbers, and I would like to see how they tie to arithmetic in mod 5. Okay, so the basic rule is that a number will always have a unique remainder sorry, I've just gone off the side of my page there, a unique remainder on division. Okay. And in this system, okay, we consider integers as equivalent. And of course, an integer is a whole number. I'm sure you know that from your computing courses. We consider integers equivalent if they give the same remainder. Okay, so let's do an example here. Let's take the example of mod 7. Okay. Okay, so what would mod 7 look like? Well, I would have 0, 1, 2, and then I would have 6, and 5, and 3, and 4. Okay, so I have my clock again. It's a 7-position clock rather than a 12-position clock, but it's still kind of like a clock. And let's say I want to see what a couple of things are equivalent to. Okay. Well, let's just take let's take the number, oh, I don't know, 19. Okay. Okay, well, of course, 19 is the same thing as 2 times 7 with a 5. Okay. So this here is the remainder. Okay. So we say that 19 is equivalent 5 in mod 7. Okay, well, let's try a negative number. Let's try the number, I don't know, minus 24. How do I get minus 24? Well, the basic procedure here is that I'm going to follow this same kind of arrangement here. I'm going to have some number of some number of multiples of 7, and then I'm going to have a positive remainder. Now, negatives people find a little bit tricky. We'll talk about how to work this out in a little while. But if you can trust me for a moment, we can see here that minus 24 would be the same thing as minus 4 times 7. That would give me a minus 28, and then to that I would have to add a plus 4. Okay. Hopefully people can see where I'm finding that information from. Okay, and it doesn't matter how big or how small the numbers get in terms of how large the integers get or how negative they get. I'll still always be able to complete this process and find the remainder here. Okay. So let's pick one more example. Okay, let's pick.
Sorry, Tom.
Yes.
Can I have a question?
Yes, absolutely.
So, speaking of the number minus 24, does that mean that we say that minus 24 is equivalent to 4 in mod 7?
Yes, minus 24 is equivalent to 4 in mod 7. Okay. Yes, absolutely. Okay. So there's another term that people use instead of equivalence. It's called congruence. Okay. Congruence. And we say two numbers are congruent in mod n, and n here is just any positive integer, okay, if they have the same remainder. On division by n. Let me give an example of that, which is maybe not obvious. Okay. Okay. So I'll pick an example here, one which is not so clear. Let's say I take let's choose the number mod 8. Why not? Okay. And let's say I have the number 21, and I have the number 53. Okay. Well, 21 can be written as 2 times 8 with a 5. Okay. And 53 can be written, okay, as 6 times 8. 6 times 8 is 48 with a 5. Okay, so it turns out that in this system, okay, in mod 8, 21 and 53 are congruent. Congruent in mod 8. Now, I know I haven't shown you how to break this down yet and how to find this information. I'll talk about that in a while. For the moment, I just want everyone to get the idea that when I say congruence, what I mean is that two numbers give the same remainder upon division by some specified number. Okay, and you can't say, are the numbers 19 and 496 congruent? That doesn't make sense. You have to say, are the numbers 19 and 496 congruent with respect to 8, with respect to 7, whatever the number might be. Does that make sense? Okay, I have to know what I'm dividing by if I'm going to talk about the remainder. Does that make sense? Any questions about that? Okay, good. I'm glad everybody's okay with this. Okay, so that's the basic idea of congruence, okay? Now, congruence has some really, really nice properties, okay? And the basic thing is congruence is really nice because it respects the standard rules of arithmetic, okay? So congruences respect the rules of standard arithmetic. What do I mean by that? What do I mean by saying congruences respect the rules of standard arithmetic? Well, I want you to take consider an example here. We'll work in mod 7 again. 7 is kind of an example that I'll pick quite a lot because 7 is small enough that everyone can see what's going on, but big enough to be a bit more interesting than like 2 or 3. Okay, and I'm going to pick two numbers here. Okay, I'm going to pick the number 10, which is a nice easy number, and I'm going to pick the number 15. Okay, 10 and 15. Okay, so let's have a look here at 10. Well, 10 is of course the same thing as 1 times 7 with a remainder of 3. Okay, and 15 is the same thing as 2 times 7 with a remainder of 1. I know I haven't shown you how to break this down yet. I'll show you that in a little while. For the moment, I just want to show you what I mean by respecting the rules of arithmetic. Okay, so that means 10 is congruent to 3. And it means that 15 is congruent to 1. Okay, 15 is congruent to 1. Now, let's see what happens if I add 10 and 15 together. Okay, well, if I add 10 and 15 together, I get the number 25. Okay, and of course, 25 is the same thing as what? Well, 25, if I break it down in sevens, is 3 times 7 and a remainder of 4. Okay, so we notice that 10 plus 15 is congruent to the 3 and the 1 added together. Can people see that? Okay, so the remainder that I get when I add two numbers together is always the same as the sum of the two remainders. Okay, so the remainder of a sum is the sum of the remainders. Now, I've only given a simple example here, and there's only 7 options, so maybe that's not very convincing. I will show you a proof of that, and don't get scared by the word proof. It just means good argument for to believe something. Okay, but I'll show you a proof of that in a second. But for the moment, let's look at multiplication. Okay, now obviously the numbers are going to get a whole lot bigger. Don't be afraid of that. Okay, well, what do I have? Well, if I multiply 10 by 15, that's an easy enough multiplication to do in our heads. That's going to be 150. That's why I picked the number 10. Okay, now what do I get if I divide 150 by 7? Well, 150 is 140 plus 10, which is the same thing as 147 plus 3. Okay, so this is actually, I believe, 21 times 7. Yes, that's correct, with a remainder of 7. Okay, sorry, not 7, a remainder of 3. My apologies. Okay, so the remainder of 10 by 15 is the same thing as what? Well, it's 3 times 1. Okay, and of course 3 and 1 were my two remainders that I had before. Okay, so congruence is really nice because it respects the effects of multiplication and it respects the effects of division. And this is very, very important. Otherwise, this would not be something that would have any use at all. Okay. So multiplication and addition are well behaved. Okay. Now let's have a little talk about why this is true. I'm going to use some kind of general terms here, and I hope it's not too upsetting to people, but I hope you can look at this. Okay. So we're going to talk about division or congruences. In mod n. So I'm moving from mod 7 to a general base. I don't know what the base is yet. It doesn't really matter. And I'm going to pick two numbers. I'm going to pick a number a. Okay. And I'm going to say that this is a multiple m1 times n plus a remainder or 1. Okay. So or 1 is the remainder for a. And I'm going to say that b then is what? I'm going to say that that's m2 by n plus the remainder or 2. Okay, so that means a has remainder or 1, and I'm going to say that b has remainder or 2. Okay, now let's have a little look at what happens when I add these numbers together. Okay, well, if I add a and b together, so say if I just take addition. Okay, addition is a fairly simple operation, or at least something that we're all reasonably familiar with. Okay, so if I take a plus b, okay, what do I have? Well, then I have m1 n plus or 1, that's my a, and to that I have to add on m2 n plus or 2, like that. Okay. Now,
Tom,
yes.
can't see the bottom of the page.
Sorry? You can't see the bottom of the page?
The first line, a plus b.
Tell me, is it not in a position you can read it?
No, I can read it. It's just that the whole page doesn't fit into the screen. So the last line that
let me see if I can adjust the camera. I'll have to check my camera feed for a second. So just is that not in? It says right click on the screen and press to fill. People are okay. People are saying it fits if you right click the screen and fill. So hopefully that should be okay. By the way, is this presentation style okay? Can people follow what's going on? Is it as good as a whiteboard in a room?
Yeah.
Yeah. Okay. So, okay, great. So let's just let's add these two numbers together. Okay. So what do I have? I have that a plus b, and all I'm going to do is I'm going to bring the n terms together and the or terms together. So this is now going to be m1 times n plus m2 times n, okay? And then I have the two remainders together, okay? I have or 1 and or 2. It's the same thing. All I've done is just shuffle the order of terms, okay? And now I'm going to do one more step. I can see that this one up here, this one is really m1 plus m2 multiplies n, okay? And then the term down here is or 1 plus or 2. Okay. So what do I see here? Well, I see here that m1 and m2 are multiplying the n, which is the base, like the 7 that I had before. And the remainder I'm going to get is always going to be the sum of the two remainders that I had before. Okay? So now this is completely independent of my choice of whatever n is, whatever a and b is, okay? This top bit here, that's a multiple of n. That's a multiple of n, okay? And this bit here, that bit is a remainder. So I've now given you a proof that the remainder of a sum is always the sum of a remainder, and I don't need to worry about it, okay? Multiplication is a little bit messier because I'm going to have some bracket terms, but it's still not difficult, okay? So let's take multiplication. By the way, I would never ask you to reproduce this. This is just for explanation. Okay, this wouldn't appear in a question or anything like that. This is just to try to explain that it's always going to work. So multiplication. What about multiplication? Well, then I would have that A getting multiplied by B would be what? Well, that would be equal to, I would have M1 times N plus OR1 would have to multiply M2 times N plus the remainder, or 2, okay? And now all I have to do is expand the brackets the way that we would have done, you know, in first year in secondary school, okay? And when I do this, I'm going to have a couple of terms, okay? I'm going to have M1 N is going to multiply M2 N, okay? To that, I'm going to have to add on OR1 multiplying M2 N. I'm going to have to add on OR2 multiplying M1N. And then finally, my last term that I'm going to get when I multiply is OR1 times OR2. Okay? But here's the important bit. All of this has an n in it. Can we all see that? There's an n here, there's an n here, and there's actually two n's in here. So this is a multiple of n, this is a multiple of n, and this is a multiple of n. So these are multiples of n. And of course, this bit here is my remainder. Okay, so I'm always going to find that the remainder of a multiple is the same as the multiple of the remainders. Okay, and I can take this as being given no matter what numbers I start with, no matter what base n I happen to be using. Okay, so this is really, really helpful. Okay, because this means that if I'm going to do a multiplication or an addition in these mod systems, I can either do it before I find remainders, or I can find remainders first and then work from there. Okay, sometimes it's easier one way, sometimes it's easier another way. Okay, let's give an example. Okay. Okay. Let's pick a big, a fairly big number, something I wouldn't like to have to work with one way, but which will be very easy another way. Let's take mod 100. Okay, so of course, you know, if I was working out multiples in mod 100, some of them would be like, you know, 99 times 84, 76 times 93, numbers that I can't work out in my head. Okay. You know, these would be quite difficult. But if we look at the additions, for example, okay, let's say I want to, let's say I wanted to, let's say I wanted to work out 421 multiplied by, I don't know, let's say 6. Let's make it 106 just for the sake of argument here. Okay, so I've got 420 multiplied, and I want to find the remainder. Okay, well, these are huge numbers. Okay, this is going to be, you know, tens of thousands. Okay, But it turns out that I can always take the remainders first, and then everything will be easy enough. I can continue taking remainders as I need to. Okay, so let's see here. 421 is going to be 4 times 100 plus 21. Okay, and 106 is going to be 1 times 100 plus 6. Okay, so that means the remainder of 421 multiplied by 106 is the same as the remainder of 21 times 6. Okay, and 21 times 6 is something much smaller that I can actually do in my head. It's going to be 126. And of course, 126 is the same as what? It's 1 times 100 plus a remainder of 26. So I never had to multiply these two numbers together to actually know what the remainder is, okay, which is the really important thing about this. Often I don't even need to know what the number I'm reducing is, okay? I have no idea what this number is. I haven't written it down at all, but I can say with absolute certainty that it has a remainder of 26 when I divide it by 100, okay? And that's a very useful property, okay? So let's do a couple of simple examples, and I'll show you now how to get this breakdown. Okay, this is really important. Okay, so how do I find the remainders quickly? Okay, so I've picked some easy numbers to work with just because it's convenient and you know, it helps me work reasonably quickly and kind of explain things as I go along. But let's now move on to how I would find remainders in general. Let's say I want to find remainders in general. Find remainders. How do I go about and actually do it? Okay, and of course I will need a calculator. Okay, you don't need one here with you today, but you know, when the exam comes, you will want a calculator. But it's very easy calculation. Okay, it's really not all that bad. Let's say I wanted to know the remainder of, let's say 132 on division by 17. Okay, I cannot do that in my head. I have no idea what it is. Okay. Well, let's see what 132 breaks down as. Okay, well, 132 divided by 17. How much do I get? Well, can people see my calculator screen there? Is it in the light? Is it visible? Yeah, good. Okay, so if I take 132 and I divide that by 17, okay, my calculator gives a fraction, but if I hit the decimal button, I see that it goes in about 7 times, 7 point something, and I always round down, okay? 7.7 something. I don't care about any of that remainder. Okay, so I'm just going to ignore all of this. Okay, there are no decimals in modular arithmetic. Okay, so what do I know? I now know that 132 is the same thing as 7 times 17 plus some remainder. I don't know what that remainder is, but I'll work it out now in a second. So in order to work out what OR is, I say 132 minus 7 times 17 has to be equal to my remainder. Okay, and now I just put this into my calculator. 132 minus 7 times 17, and I will get the number 13. So that's equal to 13. So this means that the remainder of 132 is 13 on division by 17. And of course, we could say congruence or equivalent to. Okay, so that would mean, sorry, I'm actually covering the calculation there. I didn't mean to do that. So that would mean, so 132 is congruent to 13 in mod 17. Okay, and I'm sure at this stage you're realizing that I'm writing down the phrase is congruent to a bit too often. Okay, it's kind of difficult to write this down. It takes a lot of space. So we need some notation. So hopefully you'll all follow me here. So the way we write this is 132 is equivalent to, and equivalent here has 3 lines, and we would say that that's 13 in mod 17. So this notation is just a way of compressing down the statement above here. This is completely correct. This is also completely correct. This is not wrong either. Okay, 13 is also equivalent to 132 in mod 17. Okay, it can go the other way around as well. Okay, it doesn't matter which way I write it. Okay. Now I want to talk about some different conventions, and these are important because I'm a human being and I'm bound to make slips. Okay, so some people the divisor is always the mod. Yes, whatever I'm dividing by is the thing that's the mod. Yeah. Okay. Some people write, for example, 132 is equal to 13 in mod 17, where they only use two equals, 2 bars on the equal sign. I'm almost certainly going to do this occasionally, but I will try not to. I will try as much as possible to stick to the 3-bar notation, okay? And the reason is that equality and equivalence, while they're similar in some ways, they are not the same thing. And I think that this is kind of obscuring a fact. I think equality has a very special meaning in mathematics, and we should be very careful whenever we use this symbol, okay? Another one that people use is they would write 132 is they would use the equivalent sign, and then they would put a sub 17 down here, okay? 17, and that would be 13, like that. I don't like this, only for the reason that it's very messy and very hard to read when the numbers get very big, okay? So typically, I will prefer this notation, okay? However, if you see this in a book or you see this in, a reference video or something like that, it's not wrong. It's just a different convention, okay? Is that okay with everyone? Can people follow the notation okay? Yeah, great. Okay, fantastic. By the way, normally, in a classroom environment, I would have, the opportunity to look at your faces and try to see if there's any confused looks or anything like that. Obviously, I don't have that here, okay? And I'm trying to do my best to make sure that everybody is following. But the only way that I'm going to, be reined in if I start moving too quickly and talking too much is if you interrupt me either in the chat or in the with your microphone. Okay, so I'm gonna try as best I can to take questions. Now let's do another one. Okay, we'll do another example. Let's say I take I don't know. Let's take 15 times, let's make it 8 in mod 10. Okay. How would I go and do this? Okay. Well, I can, as I said, I can either do this 2 ways. I can work out the 15 times 8 in the beginning. 15 times 8 is what? 15 times 8 is 120. So that would be 120 mod 10. Okay, and then I would have that 120 is equal to 12 times 10 with a remainder of 0. So that would mean that 15 times 8 is going to be equivalent to 0 in mod 10, and that's totally correct. Okay, if I want to work out the multiplication first, that's fine. Okay, however, of course, I can decide instead that I would rather work out the remainders first and work from that point of view. Okay, so I would say that 15 is 1 times 10 plus a 5. I think we can all see that the numbers are small enough that we're going to know what the remainders are here. And 8, of course, is no times 10 plus a remainder of 8. Okay, so now 15 times 8 must be congruent to 5 times 8 in mod. See, I'm already making mistakes. I'm already slipping. So I'll try to keep the 3 bars there. In mod 10, and of course that's 40 in mod 10. And of course that would be 0 as well, because 40 is 4 times 10. Okay, so I can work in both directions there. And I want to talk a little bit about negative numbers because people find negative numbers a bit difficult, and it's not quite so clear how you should go about doing it. Oh, sorry, this is kind of causing me some trouble here. How did the 40 change to 0 there? Well, the same way that I would have done here. Okay, so 120 would be 12 times 10, well 40 would be 4 times 10 with a remainder of 0. So I can determine that the remainder has to be 0 in that case. Does that make sense? Connor, is that suitable? Does that make sense? Yeah, okay, great. Okay, so let me now talk about how to find it for a negative number. Okay. And of course, if I needed to do this on my calculator the way I did for the 132 and 17, no problem. Use your calculator. Okay, that's what it's for. Okay, so let's now have another look at, let's say, minus 93 in mod. That. Okay, am I back? Hello? Am I back? Great. Okay.
Yeah.
I think I accidentally hit a key on my keyboard there. Okay. So let's talk a little bit about a negative number. Okay, and how I would go about that. There's 2 opportunities here. Okay, 2 possibilities. The first, you don't need to do it both ways. Just pick a way that you like and get good at it. The first way is to find a negative multiple with a positive remainder. People don't like this one so much, but it's actually the way I think about it in my head. Negative multiple with a positive remainder. Okay. Okay, negative multiple with a positive remainder. Okay, so how would I go about this? Well, I would be trying to find the multiple of 18, which would actually be below minus 93. So again, what do? I put minus 93 onto my calculator, and I'm now going to divide by 18. Okay? And what do I see? Minus 93 divided by 18. and I have that this is minus 5 point something. Okay. And you'll remember, if you just let me rewind a little bit here, okay, what did I do in this case? Well, I rounded the number down. Okay, I rounded the 7.76 down to 7. Okay, well, I'm going to do the same thing. I'm going to round this down. Okay. I'm going to round down to minus 6. Why am I rounding down to minus 6? Because this way it's consistent with the previous work. And I will now find that minus 93 is equal to minus 6 times 18 with some remainder, and that remainder is going to be positive. So that would be minus 93 plus 6 times 18 is equal to my remainder. So what's my remainder? Put this into my calculator again, minus 93. And now I have plus 6 times 18, and I find that my remainder is 15. Okay. Okay, so minus 93, and that one's it's not very clear to look at that. That would be equal to 15. Okay, so that's one possibility, is that I work this way. This is actually the way I do it, and the reason is because it means I'm always doing exactly the same procedure. I'm dividing by my number, and I round down whatever I get. Okay, this is my preferred way. For whatever reason, most students don't like it so much. If it's Kira, you've got your hand up there. Do you want to ask a question? Hello? Somebody raised a hand there. Do they want to speak?
Sorry, yeah.
Yeah.
I just wanted to ask, in the previous example, we have rounded up to 7.
No, I never rounded up. I rounded down. Watch here.
Oh, I rounded down. But in this case...
You see, so I rounded down.
But so in this case, we round up?
No, in this case, I'm still rounding down. But down from minus 5 is not up to minus 5. Down from minus 5 is down to minus 6. Does that make sense?
Yeah, thank you.
Yeah. So this way actually is easier to program. If you were actually to make a program for this, it would actually be easier. Okay. However, a lot of people find rounding down a negative number to actually get the number below it kind of counterintuitive. Okay. So how else can I go about doing it? Okay. Well, the other way. Okay. Well, the other way is I don't like it as much. Other people do. They like it better. So let's talk about it. The first step is to make it positive. Okay. So what do I have now? I would have 93. Okay, instead of minus 93, I would then divide by my 18. Okay, and that would be 5 point something. Okay, whatever. Okay, 5 point something. And now I could say that 93 was the same thing as 5 times 18 plus a remainder. Okay, and then I would have 93 would be the same thing, minus 5 times 18 would be my remainder. 5 times 18 is 90, so that would give me a remainder of 3. Okay, now I make it negative again. I can make it negative again. Okay, and then I would have minus 3. Okay, and now this has to be congruent to 18 minus 3, because this is just a multiple of 18, and of course 18 is kind of like the 0 in my system. So taking 3 steps back from 0 has to be the same as taking 3 steps back from 18, and this is in mod 18. Okay, and of course that is 15 as well. Now, I'm going to say absolutely unreservedly, this is my favorite way of doing it. I prefer to do it this way, okay? However, other people have told me they find this more comfortable. They find it easier to keep track of positive numbers and then just change the sign at the end. If people are having a little bit of difficulty visualizing this, okay, I'm going to pick a really easy example just to show you something here. Let's take the really simple example of, say, -9 in mod 6. Okay, so small numbers, easier to see, okay? And let's say I made it positive first. So I would have 9 being divided by 6, and that would be 1, okay, with something afterwards. Okay, I would say that 9 minus 1 times 6 gives me my remainder, and of course in this case my remainder is 3. Okay, so now what do I have? Well, now I would have that 9 9 is congruent to 3 in mod 6, so that would mean that -9 has to be congruent to -3 in mod 6, but I don't want to work with a negative number here. I'd like to get the positive remainder, okay? And of course, what I can do here is just keep adding on multiples of 6, going around my clock in either direction until I get a suitably large number, okay? And that would be 12 minus 3 in mod 6. Sorry, 6 minus 3 in mod 6, which is just 3 in mod 6. And of course, let's go back to the picture of the clock here just for a moment so that we can kind of picture this a little bit more. Okay, so what did the clock in mod 6 look like? My clock was 0, 1, 2, and then 3, 4, and 5. Okay, so now say I want to find out what -3 is equivalent to. That's 1, 2, 3 steps to the left. Okay, that's the same as taking 3 steps to the right. Okay, so a negative number will always be equivalent to some positive number, and in fact it will always be, in this case, 6 minus 3, or the base minus whatever the positive remainder was. Does that make sense to people? Is there anyone who's confused about that? Are these yays for confusion or yeses for understanding? Maybe we might need a code here. Is you like the other method? Yeah, okay. Some people say they like the other method better. I absolutely agree. I prefer the first way and always rounding down. That's my preferred method. However, you know, the kind of thing about this is that because we have because the rules of arithmetic are respected so well by this system, I have a lot of different options, you know, and I need to be able to understand. I need to be able to understand that there are multiple ways that I can go and do things. Okay, so that is the idea of how I'm actually going to go and find the remainders and find general congruences. Okay, and I'm going to show you one last little trick, which is very helpful because it can be. I now know how to find any remainder. Okay, I've seen how to do that, but let's say I have two numbers a and b. So suppose in mod n, we want to decide if a is congruent to b in mod n. So what does that mean? It means they give the same remainder. Okay. I want to know if they give the same remainder. I don't necessarily care maybe what a and b are, but I want to know what the remainder is. Okay. But if they have the same remainder. Okay. Well, one thing I can do, okay, one thing I could do is just find the remainders for a and b like I did before. And of course I could do that. There would be nothing wrong with it. But remember, A will always have the general form where it's some multiple of n's plus a remainder. I don't know what that remainder is. I don't know what the multiple is, but I know there's some general form here. Okay. Now let's say I take B here and I have some multiple of n's plus some other remainder. Okay. Well, now let's consider this. What's A minus B? What's A minus B? Well, A minus B is going to be M1n plus or1 subtract M2n plus or2, and that's going to be equal to, maybe I'm going a little quick here, but maybe you can follow me, I hope so. This is going to be M1 minus M2 gets multiplied by n, and then I'm going to have plus or1 minus or2, okay? And of course, this bit is a multiple of n, okay? Which means that bit doesn't really matter, okay? The only bit that matters is this bit, okay? So I said before that the sum of the remainders was the same as the difference. Sum of the remainders was the same as the remainder of the sums. Well, here the difference of the remainders is the same as the remainder for the difference. Okay, and this is the really important thing. If or1 is equal to or2, then necessarily or1 minus or2 must be equal to what? Any guesses? If two things are equal, what's one minus the other? 0, right? So what does that mean? Okay, that means the only way that A and B can have the same remainder is if when I take the difference, whatever that is, it has remainder 0. Okay? Okay? So A and B are congruent if and only if A minus B has remainder 0. But what does it mean to have remainder 0? Well, that means that when I divide, I have no remainder. Okay? Which means A minus B is a multiple of n. So instead of working out the how everything, how both the A and the B break down and find their individual remainders, I may not actually need that information. I may not need to know what the remainder for A is and what the remainder for B is. I may only need to know if it's the same remainder or not. And in mathematics, we generally try not to compute things that we don't need to know. Okay, and of course, in computing, it's very important as well because you don't want to waste computing power finding out both of these remainders when all you need to know is if they're the same or not. Okay, it turns out that answering whether they're the same or not is much simpler. All I have to do is find the remainder of their difference, and of course, difference is much simpler than multiplication to do for a computer to do. I'm sure you all know that a computer essentially turns all multiplications into additions, and additions are cheap and multiplications are expensive. So where possible, we would like as much as possible to only work with additions or subtractions. Okay, so that's what I'm going to do here. Okay, we'll have a couple of examples. Okay. Let's do some examples. Let's say I want to decide if I may take an example from the notes here just to just for the sake of, nah, it's okay, I can make them up. Let's say if I want to decide if A and B are congruent. In mod. And now I've already said, okay, that I can go and I can actually work out what the remainders are in both cases. I'm not going to do that this time, okay? I'm going to have an example here. Example 1, I'll choose A to be 24. I'll let B be 58. And I will let N equal 17. Okay? Well, I'm not going to work out the remainders for either of these. That's computing time that I don't want to spend. All I'm going to do is take A minus B, and I see that that's 24 minus 58, which is a total of minus 34. Now I divide minus 34, and what do I have? Minus 34 gets divided by 17, and the answer I get is minus 2 with no remainder. Okay, so I never worked out what the actual remainder for A and B is, but now I know it has to be the same thing. Okay, and often I don't need to know what the remainder of each of A and B is. I only need to know if it's the same thing or not. And a lot of the time, this is a very helpful trick. Okay, so a lot of the time when we need to determine whether numbers are congruent, but we don't necessarily need to know what the actual remainder is, we'll tend to do it this way. Okay, I'll do another example. Okay. Do another example. Let's take A is 36. Let's make B 492. And let's make N, random number off the top of my head, 19. Okay. This one is now hard enough that I don't want to have to waste time finding the remainder of 492 in mod. Can I move the calculator? Oh, I'm sorry. Please do tell me if I'm doing that. I'm just trying to, the desk space I have is quite small here, so I'm trying to keep everything within arm's reach. Okay. So this is now difficult enough that I wouldn't want to have to find the remainder if I don't need to. Okay. If it's at all possible to me, for me to do, I would like to find the answer to whether they're congruent without actually having to go and compute the remainders. Okay, so what would I do? A minus B, what is that? Get my calculator here. Okay, so now I take 36 minus 492. Pretty easy to do on a calculator. That's 456 with a negative sign. Okay, I take minus 456. I'm going to divide that by 19. And what do I get? Divided by 19. And I can see that it's exactly equal to minus 24. Okay, so by pure fluke, I've managed to pick two congruent numbers. I did not plan that. Okay, with no remainder. So actually congruent. Okay, I don't know what the remainder is. I could probably find it very quickly because 36 is small enough. I think it would have to be 17. Yes, it would. But I didn't know that going into this question. All I did was find their difference and divide it by 19 and check whether the remainder was 0 or not. Okay, and a lot of the time, this is actually all the information I would need. I don't necessarily need to know if I don't necessarily need to know what the actual remainder is, which is very, very useful for me to use this trick when I don't actually need the full information. Of course, sometimes, sorry, I thought somebody was asking a question there, but I thought the hand raise icon came up, but it didn't. Are there any questions about this procedure here? Is it okay?
Yeah, sorry.
Sure.
Will we get some examples to practice?
Sorry, will you get examples to practice? Yes, if you go to the, so let me share a screen for a moment here. Share screen. So this is my section 2 here. Can everyone see this now?
Yeah, we can, yeah.
Right, okay. So there's a lot of problems here that you can practice, okay, throughout the course of the notes, okay, and you can practice them. Generally speaking, what I'll do is make up numbers off the top of my head because I'm fairly comfortable that I can get the right answers at this stage of my career. But so, for example, here we were looking at this kind of case here where we look at the remainders. Is 15 congruent to 33 in mod 6? Well, I can either work out the remainders, in which case it would be 3 for both of them. 15 is 12 plus 3. 33 is 30 plus 3. However, if I decide 15 minus 33 instead, we can see that that's minus 18. And of course, minus 18 is a multiple of 6 itself. And that's a faster check in some cases. Okay, so this is there are questions in the notes here that you can always try throughout. However, it's not difficult to come up with examples of this. Okay, just write down two numbers and pick an n, and check to see if they're congruent or not. Okay, I can write down any two numbers and any n and check to see if they're congruent. It's not something that depends on the choice of numbers I pick. Okay. So you can make your own exercises pretty easily too if you would prefer to do that. Is my camera available to people again? Is my camera back? No? Camera's back, great, okay. I had some difficulty when I would switch off screen share. Great. I would have some difficulty last night when I switched off screen share and all I got was a blank screen for a little while and I had to restart my camera, but it seems to have sorted itself out. So any examples you can think of, it's easy to make up examples. I can pick any numbers I like. And I don't want to give you the impression that this only works for small numbers or anything like that. So occasionally I'll pick examples which are very big, and we're going to see that everything works out just fine too. Okay, and in fact, very big numbers are very important. Specifically in encryption, okay, which is very important that you have a strong crypto system. And the way you ensure a strong crypto system is that everything gets done with respect to essentially a very large n, which is a factor of only two prime numbers. Have people heard of RSA encryption? Is that a thing people have heard of? RSA? Yeah. RSA is the lead. RSA encryption is the leading method of encryption used in most circumstances. It's called an end-to-end encryption or a private key encryption or a public key encryption, which basically all means the same thing, which is kind of confusing. But RSA is an extremely strong encryption. It's a little bit more advanced than what we can go through in this module, but by the time you finish this module, you'd be able to start reading about RSA yourself and start learning how to do it. Okay, and we will look at examples of kind of easy crypto systems before too long. Okay, so generally speaking now, we have a couple of ideas. We have the basic idea of what a congruence is. We have the basic idea of how they work. We know how to find the remainders. So everything is going fairly good. It's still going to be a bit of a while before I can talk about an application. I need to talk about something called equivalence first. And I said things are equivalent, but equivalence. Okay. If my spelling is wrong, I apologize. I don't have a degree in English. I'm not even particularly good at spelling. So what is an equivalence? Well, let's look at some properties of a congruence. What is equivalence? Well, let's look at properties of congruences. Okay. And the properties of congruences are not the same as equality. Okay, so for example here, I just showed in the previous section here that 36 was equivalent or congruent to 492 in a system mod n 19. Okay, mod 19, I showed that these two numbers are congruent, and we're going to show that they're actually equivalent in this system. But I'm not saying they're equal. 36 is the number 36, 492 is the number 492. They are still distinctly different items, okay? But let's look at properties of equality first. So for a general equality, for any equality, we have some basic properties. Okay, some basic properties. The first, and this one seems extremely simple and almost stupid to say, but it's very important. Okay, for any A, okay, for any number A is always equal to A. Okay, A is always equal to A. A is equal to itself. Okay, so that's something that's very important. Okay. Second property is that for any A and B, okay, if A is equal to B, well then B is equal to A. Does everyone agree with that? Okay. The equality symbol doesn't pick a direction. It's not important. Okay. Order doesn't matter in equality. Okay. And the last property that's very important, which makes equality a very useful tool, it's something very important to have, is for any numbers A, B, and C. I can't see the bottom of the page. Can you try right-clicking the video and sending it to full screen? That apparently works. Sure. Okay, great. Okay, so for any A, B, and C, okay, if A is equal to B and B is equal to C, then we can conclude that A must also equal C. Okay? So this is very important. If A, B, and C have this property that A is B and B is C, then A is most certainly C as well. Okay? These have names. One is called reflexivity. Reflexive. Now, you don't need to be able to reproduce these names. I'm just giving them to you for your own sake if you want to Google them or anything like that. 2 here is called symmetric. And 3 is called transitive. Okay, so reflexive, symmetric, and transitive. These are 3 properties of equality, the standard equality of numbers that you're all familiar with, okay, which are absolutely foundationally important. However, equality is not the only thing with these 3 properties, okay? There are other relations besides equality with these properties, okay? And anything that has these 3 properties we call an equivalence, okay? Anything with these 3 properties we call an equivalence. Any relation with these 3 properties is an equivalence. Now, I want to talk a little bit, please don't think this is a rant or politically motivated at all, but in the case of mathematics, equality has a very special meaning. If two things are equal, it means that they are not two separate things. It means that they are the same thing, merely described in different ways. So, in the sense of mathematics, the only person on Earth who is equal to me, Thomas Gilroy, is me, Thomas Gilroy. Everybody else is different. You are distinguishable from me, and therefore you are not the same. Now, so in a mathematical language, none of you are equal to me. I am not equal to any of you, and so on. Okay. Equivalence, on the other hand, in mathematics means that things have some kind of similar behavior, or that one is as good as another in some certain context. Okay. So I'm certainly not saying that you know the discussion around equality or anything like that in the broader social spectrum is wrong or anything like that. I'm just saying, specific to mathematics, the only things that are equal to each other are the same things. Okay, so why is 7 minus 2 equal to 5? Well, it's because they're the same thing. 7 minus 2 is just a different description of the same object that 5 describes. Okay, we're going to see here that although in this previous case here I said that 36 and 492 are congruent, we're going to see that this is an equivalence. Okay, one is every bit as good as the other in a certain context, and that context is mod 19. Okay, however, I am never ever going to tell you that 36 is equal to 492. Okay, these are different numbers. Does that make sense? Is that something people can agree with my terminology here? When I say equal as a mathematician, I mean two things are exactly the same. When I say equivalent, I mean that one is as good as the other in some kind of context. That one is completely has the same purpose or the same role or something like that. Okay, so my terminology here is a little bit different from kind of standard terminology that you might use in kind of English parlance, but I have to be very precise, otherwise things are going to get a little tricky. Well, here's the important thing: congruence has these properties. Okay, congruence has those properties. Okay, so that means congruence is an example of an equivalence. Mod n is an example of an equivalence. Of equivalence. Okay. And I'll prove that. Okay, I'll prove that to you all. But for the moment, what I'm going to show you is that because certain properties are upheld, in fact, these three important properties of equality, I can kind of treat equivalence as being like equality in a lot of cases, but I have to be careful about where they are not the same thing. Okay, so let's talk a little bit about how I can show that these these properties are upheld, and then we'll potentially maybe leave it there and just take questions for the end of the class. So congruences in general. I'm starting here. Well, let's have a think about it. Remember, A and B are congruent mod n. What does that mean? It means that A and B have the same remainder on division by n. By n. Okay. Well, let's just look at these properties here. Is it reflexive? Is it reflexive? Okay. Well, A will always, always have the same remainder as itself. Okay. Okay, so if 12 has a remainder of 2 on division by 10, then 12 has a remainder of 2 on division by 10. Okay, so certainly A will always be congruent to A in mod n for any A. Okay, that's always going to be true. That one's easy. Okay. What about the other ones? Okay. What about A and B? 2. Well, if A has the same remainder as B, okay, well then B clearly has the same remainder as A. As A. So what does that mean? That means that if A is congruent to B in mod n, this implies in either direction that B must also be congruent to A in mod n. Okay. And the last one to think about is the transitivity. And of course, that works in exactly the way you expect, okay, which is that if A has the same remainder as B, and B has the same remainder as C, then A and C have same remainder. Okay, A and C have the same remainder. And of course, the way we would write that is that if A is congruent to B in mod n, and I have that B is congruent to C in mod n, this implies that A is congruent to C. Okay, so in this sense, it's very simple to see this, of course, that it makes obvious sense, but I'm just showing you, I've just easily checked the 3 basic properties, which are important for me to be able to say that something is an equivalence, that something works a bit like equality in the mathematical sense. And I want to remind you here that I'm never saying that A and B are necessarily the same thing. I'm not saying they're equal. In this previous example here, I was not saying that 36 and 492 are equal as numbers. They are most certainly not. Okay, you've known that for your whole life. Okay, so please, what was it? What did I write? 32 and 496, or was it 36? Yeah, 36 and 492. Okay, so we saw earlier that 36 is absolutely, most definitely congruent to 492 in mod 19. We got lucky. We found one that was just happened to be true. Okay. However, we cannot .36 is equal to 492. Okay, it's been wrong your whole life. It's still wrong. Okay, so please please respect the importance of this symbol. Okay, can I put the end of the page at the same side as the camera view? Sorry. How's that? Okay, yeah. This is kind of unfortunate, but I actually can't see the camera when I'm working on the. Can't see what's in the camera feed when I'm working on the page. Okay, so if things go out of view or if they get a little bit difficult to see, let me know. I'll do my best. Okay, so please respect the importance of this symbol. When I say equality, I mean equality. I mean they're the same number. I mean that things are exactly the same number. Okay, when I write this symbol, 3 bars here and mod 19, I may occasionally forget the third bar, but I will not forget the mod 19. Don't worry about that. I mean that they're equivalent in this system, okay? And it turns out that when I'm working in mod 19, anything I do with the number 36 is exactly the same as what I would do with the number 492. If I multiply by 36, it's the same as multiplying by 492. If I add or subtract a 36, then it's the same as adding or subtracting 492. All it is just a different number of loops around my clock, okay? Does that make sense? Before I find my resting place, they have the same resting place on the clock once I finish my rotations. Okay. Are there any questions at this stage? Is that okay with people? Does anyone want to get something clarified? All good from some people. That's great. People are good. Okay. Just general feedback. How's is everything clear? All can be followed on the screen and everything like that. Yeah. Okay. Like I said, general plan is that I will get a screenwriter. Okay. Now, how long I'll be waiting for a screenwriter is not up to me. Okay. But I can guarantee you I'm not buying one myself. Okay, because I've been told that I should be getting one. So I've been told that I should be getting a screenwriter, and that will probably come, a couple of weeks, maybe. I don't know. Maybe hopefully next week, but probably not before Monday. And once I get it, I will switch to using the whiteboard facility that's built into Teams, hopefully. Okay. And then once that's done, I can export the whiteboard to a PDF and share it. Okay. I would put that up on the Moodle page as well. And that could be, something you could refer back to. If I have to continue with this kind of handwritten presentation, which I hope I don't have to do for 2 reasons. First of all, it's an incredible waste of paper. That is the amount of paper that I've gotten through. That's probably about 20 or 30 pages now. It's an incredible waste of paper, and I feel bad for the. I probably what I'll do is I'll probably start taking refill pads from the office stationery sections, but it is an incredible waste of paper. I don't like it as an environmental thing. It's not something I it's not something I really want to do. I would rather not be wasteful. So where possible, if it is possible, I will switch to the screenwriter. On the other hand, I have to keep doing this. When will the recording be uploaded? Okay, so once I finish the recording, it takes about 15 to 20 minutes for it to get exported to Microsoft Streams, and then it should be available at the end of the chat for this lecture. Okay, so you can go back and find it there. However, my feeling is that will probably get lost to time. Okay, that would just be, will I send you the notes? Yeah, so this was the kind of thing I was mentioning here about the paper presentation. I would love to be able to scan all of this and just put it up as a PDF on the page. and when possible, I will do that. However, I don't have a scanner at home. Okay, so it might take, there might be a bit of a delay in getting the notes available to you. However, the actual video presentation, yeah, I'm not gonna go through the process of sitting down and making sure that every scan is clear on the phone. Okay, that's not really practical for that many pages. What I would do is I would go into the office, scan them one page at a time using the facilities of the office scanner, and just, you know, export a document all in one go. That's very easy for me to do. So, yeah, still not doing it with my phone. Okay, so it's just on, you know, it's an, like, to scan that on my phone would take me half an hour, whereas to stick it into that would take me absolutely a really long time. If I stick this into the office scanners, it will just be done in, you know, 30 seconds. So I'll wait until I can bring this into the scanners in the office, export it as a PDF or multiple PDFs, and then I'll put that online. So there might be a bit of a wait, sorry, before the handwritten notes are available. Okay. However, once I'm provided with a screenwriter and I switch to using, how about I take my own which, so the re yes, I can take a picture of each individual page, and then I can collate them and make sure that the document looks okay, and then I can upload that, which will be, I can take a picture of each individual page. I'm not going to do that. What I will do is I will gather the pages into a pile, stick them in, oh, for the student. Oh yeah, you can do that. What I'm going to do is I'm going to gather all the pages into a pile, stick them into the scanner. That'll all be done in 30 seconds once I have the right scanner. Okay, so I'll do that when I can. Once I have the screenwriter or a stylus, okay. Once I have the screenwriter or a stylus, I will be able to work on my whiteboard here in the Teams presentation, and I believe that can be exported. I believe that can be exported to PDF immediately. Okay, so everybody should have the access to that at that stage. Okay. As for how long it takes for the video, I think it's about 15 to 20 minutes of processing, at which stage it becomes available on Microsoft Streams. However, you have to be logged into the college network in order to be able to use it. So I will download that and upload it to my YouTube page as an unlisted video, and you will be the only people with a link to it. And then at the end of the semester, I will delete them all so that none of your information or any of your comments can ever be found again. Okay, so I hope is that an acceptable use of people's data? Is that something that you feel is worth the trade-off? Yeah, great. Okay, so that's my plan. Now it comes out, the recording comes out okay, but the camera doesn't fill the full screen, and I haven't yet figured out how to ensure that happens. Maybe I'll figure that out for later videos. For the moment, it fills the upper left corner, and it's still pretty readable. I checked the lecture I did last night, and that was fine. So that should be okay. And have I any other suggestions or oh, if anyone's wondering about a book, there isn't one. Okay, there's no book that I would recommend for this module. Just read the notes and pay attention to what I'm saying. It should be fine. And when we get closer to the final exam and it's time to work through some exam type questions, I will make some videos in this way here, kind of with the over the shoulder presentation, and I will record them, and then I'll host those as unlisted videos as well on YouTube, and you'll be able to find them. You don't need to subscribe to my YouTube channel or anything like that. I'm not trying to become famous. You can look through my other videos if you want, if you're interested in advanced guitar technique or videos of me competing in Brazilian Jiu-Jitsu, but hey, it's up to you guys if you want. It's just the only I'm not going to set up a new channel for that. Or I'm a light blue, light blue, late blue belt. Can you play? No, I'm a little shy about playing music in front of people. But if you want guitar technique criticized and you want a bit of a commentary on what I think you might be able to do better, I've been playing for 20 years at this stage. I can probably give you some meaningful advice. Have I anything else to say? So yeah, that's as for sharing notes, things like that. Videos of me in it or something. I don't really care. Okay, I used to work in China, and students there just used to take pictures of the blackboards, and I was obviously in all of them. Okay, so there are thousands of pictures of me on Chinese social media, standing next to blackboards. So I'm very used to, my image being out there. Just please don't, make memes out of me and put them on Imgur or Reddit or something like that. Beyond that, I don't really care whatever you do with a video that I'm in or anything like that. I don't care. But if what I would tell you, and this is very clear, is while I'm okay and I'm not going to get upset about you sharing videos or linking to videos on social media or whatever it is, there are other people's data here. So I can see the names of students, I can see their student numbers. That's private information that you do not have permission to share. Okay, so make sure that you're only sharing it among the class. Okay, that's very important. Otherwise, you are in breach of GDP, or I am not. Okay, you would be overstepping your bounds, and you would be at fault. Memes of me are fine, provided you blur out everybody else's names. Well, please don't do it, but you could. I can't stop you. So please, but make sure you respect the privacy of the other students in the list. Did I get my blue belt in Ireland? Yeah, my coach is Marius Domisat, who is a black belt under Piotr Baginski and Felipe Costa, and he's a champ. It's either Grapple Kings or Grapple Fest. He's the heavyweight champion in one of them. He's a very good coach. But as for the Monday lecture, I will organize the meeting for that, and I will send out the link. It's a 2-hour lecture. It's only 1 hour on the timetable, but it will be 2 hours. And you can, if for some reason you've been planning on a 1-hour lecture on Monday and you can't stay for the full thing, or you have some other commitment that you have to work with, that's fine. Remember, the video will be available for you, and you can check it out. And I would very strongly suggest, please don't violate the privacy of the other students, and do not assume that anything I'm telling you about me being okay with sharing my likeness or a video of me in it with another student being okay for me. Do not take that as being saying it's okay in general with other lecturers. They are entirely within their rights to be upset if you do that. Okay, so we're all trying to figure it out, but for me, I'm kind of an open book. I don't really care. Okay, so that's it for today. If you've any final questions, I'll stay on for a few more minutes. If anybody else wants to leave at this stage, you're totally welcome to. If you have any feedback, you want to say anything, you want to tell me if there's something about the presentation that's not great for you, I'll do my best to fix it. Okay. However, there are limits to what I can actually achieve. Okay. Any questions? Any hands to be raised? Okay. For the problems on, sorry, just let me read this this chat here. For the problems on Moodle, will you be releasing more, or is that meant for the whole year? Later on in the, we will primarily start looking at exam type questions after a while, and we have a huge backlog of them that we can look at. So Joe, you don't need to worry about having a lot of examples. There will be plenty done, okay? And if you decide you want to, of course, work on an exam question ahead of time and then show me your work or ask me a question about where you get stuck, that's absolutely fine as well, okay? If you have any email, if you want to ask me a question, there's something you're trying and you don't know how to do it, what I would recommend is that you just take a picture of what you're doing. Don't try to write mathematics. That would be an absolute waste of time. Just take a picture of what you're doing, send it as an email attachment to me, and then I'll look at it when I have a chance, and I will go from there. I'll be able to figure things out. Okay. So if there's no more questions, I'll leave. Okay. Thank you, everyone. I'm gonna hang up now. Audio's gone. Some people can still hear. Okay. So I'm going to leave now. Unless there's any questions, you've got 30 seconds. Okay. While I have just enough time here to end the recording. Okay. So the recording is stopped in 3, 2, 1 now. Okay.